Hello everybody, my name is Esteban. I'm a PhD student at Università Svizzera Italiana in Lugano, Switzerland. I'm going to present our work in collaboration with Mohammad Aliannejadi, Manajit Chakraborty, and Fabio Crestani, titled Harnessing Evolution of Multi-Turn Conversations for Effective Answer Retrieval. Recent emergence of intelligent assistants such as Microsoft Cortana and Google Assistant have led to an increase in research interest on conversational systems. In this work, we investigate multi-turn dialogue-based conversational systems for information seeking. As literature has shown, multiple turns in a conversation can be used to understand the user information need more effectively. Despite this, not much is known about how users interact with a conversational system in a multi-turn setting, and how other utterances can help the system to understand their information need. Motivated by this, in this work, we aim to provide an understanding of user behavior and how their information need evolves during the course of a multi-turn conversation. For instance, consider the following conversation extracted from CHIIR 2019 dataset, and suppose that we currently want to answer question in utterance number 8. As we can observe, the questions cannot be answered unless additional information from previous utterances, that is, the context, is included in the question. In this case, utterances 1 and 6 provide the necessary context, and therefore they are relevant to utterance number 8. Here, we're presenting the pipeline that we have designed to conduct the proposed analysis. In essence, given an utterance, the idea is to identify the relevant context from previous utterances. To do so, we propose various heuristic and machine learning-based approaches. And once that we have identified the relevant context, the next step is to reformulate the utterance to create a query, which would be then used to retrieve the relevant documents. Since we are interested in understanding the dependency of conversation turns, we have annotated each turn of the conversations in the CHIIR 2019 dataset with related turns in the conversation's context. This dataset, which we called CASTUR, has been released for public use. Since CASTUR in Spanish means beaver, is why we are seeing our little friend here. So, how was the annotation process? Well, given a conversation, 3 human annotators were asked to select 1 or more utterances which could help to better express the information need presented in the current turn of the conversation. What we are seeing here is the result of the annotation process. One takeaway here is that 71% of the utterances only have 1 relevant turn, while less than 1% has 3 and 4 relevant turns. On the left, we are studying the evolution of the conversation. In general, the conversation topic evolves or changes with each turn. Here, we are studying the difference in position of the relevant turn with the current turn. As we can observe, for a large share of the utterances, the relevant turn is found in close proximity. On the right, we are studying the relation between position of the current utterance and its relevant turn. In most conversations, the first 7 turns are mostly dependent on the first turn, suggesting that users explore a single topic in several turns. If you are interested in these and other analyses that we have conducted, we refer you to the paper. Once that we have a better understanding on the dependency and evolution of conversation turns, we are now interested in investigating different strategies for selecting relevant utterances, that is, to identify the conversational context. Recall that the goal is to maximize the retrieval performance, and we want to do that because we need to identify for the current utterance the relevant context. We have proposed various heuristic approaches, and also we have posed this task as a prediction task, and to do so, we have evaluated various classifications approaches. In particular, we discovered that a model which integrates BERT gives the highest performance. In fact, as our analysis shown, the relative distance of 2 utterances is negatively correlated with their relevance, and therefore, this requires joint modeling of the utterance's language and position in the conversation. Using BERT, our model learns a high-dimensional language and position representations for predicting the most relevant utterance to the current one. Again, if you're interested to know more about the different models that we have evaluated, we refer you to the paper. Once that we have identified the relevant context, the following step is to reformulate the utterance to include the context that has been identified and create a query. In this case, we perform coreference resolution when applicable, we remove stop words, and we tokenize the utterance to create the query. We have evaluated 3 different term matching models, which are listed here. Given the lack of space and time, we only show the results of the query likelihood retrieval model. More information about this and the other models can be found in the paper. I will quickly explain which are the heuristics that were used to compare against our prediction model using BERT. FU stands for first utterance, which in essence always chooses the first utterance as the relevant context. PU stands for previous utterance, which always chooses the previous utterance as the current context. FPU always chooses first and previous utterance as the relevant context, and AU chooses all the previous utterance as the relevant context. Finally, we have PRU, which is our proposed model based on BERT. As we can observe, our model using BERT core provides the highest retrieval performance by selecting the relevant utterances to the current one. Finally, we're also interested in studying metric-oriented selection of relevant utterances with our prediction model. The takeaway here is that precision-oriented selection achieves the largest retrieval performance. This gives the intuition that this task is highly precision-oriented. So, wrapping up, we have shown that identifying the proper context for an utterance, it's important to enhance the retrieval performance. We have shown different heuristic and machine learning based models to select relevant utterances, and we have studied their performance in a retrieval task. This has shown that VERCORE has the largest performance, and finally that what the analysis shown is that retrieval models reflect that precision matters for this task. If you're interested in downloading the dataset, we refer you to our GitHub repository where you can find it. Thank you very much and have a nice day.